Hey GED students, I had a student, Robin, send me this super tricky area perimeter problem. So that being said, I just want to warn you guys, this is probably a little more challenging than what's actually on the GED. So if you're just looking for GED prep, you could just skip this video. But for Robin, who always wants to know how to figure things out, and for those of you who are college bound and really trying to develop those reasoning skills, this is great practice and reviews a lot of different things that are on the GED. So let's take a look. It says an isosceles right triangle has an area of 32 square inches. Let's stop right there and make sure we understand this language. So first of all, isosceles. When you say that a triangle is isosceles, that means it has two sides that are equal in length. They're congruent. Congruence, just kind of like the fancy word we use for equal in geometry. They're the same length, okay? So two congruent sides, okay? And then if you say that it's a right triangle, that means that it has a right angle on it. Okay, so I'm going to draw out this triangle we're looking at. So here's my isosceles right triangle. Now I happen to know something that you might not know that makes this problem a little easier. I know that when a right triangle is isosceles, the sides that are equal are always these two sides. Because the hypotenuse, that's the side across from the right angle, is always the longest side. So if we're looking at an isosceles right triangle, I know that these two legs, the two sides around the right angle, are going to be congruent. They're going to be the same length, okay? Now, I know another thing about my triangle. I know its area. The area is equal to 32 square inches. Now, look, I know another thing. Oh, hallelujah. The hypotenuse is 11.3 inches. Okay, cool. So that hypotenuse there is 11.3 inches. Notice, I haven't done this problem yet. Robin gave it to me. I wrote it down. I started doing it. I haven't figured out how to do it yet. I'm drawing a picture to get myself together to know what's going on. If the math teacher needs to do that, how much more does the math student need to do that? Don't skip this step, okay? It really helps me to see what's going on, okay? Now, it says, what is the perimeter to the nearest inch? Now we have a problem. What is the perimeter? They want me to find perimeter, which is pretty simple, whether I'm using the formula for the perimeter of a triangle, P equals S1 plus S2, plus S3, or I'm doing perimeter by definition. Perimeter basically is just all the sides add up the length of all the sides, give me the total length around the shape. I would do it the same way, I would just add up the three sides, but the problem is I don't know the three sides. I know one of the sides, I know the hypotenuse, but I don't know the length of those legs. Okay, so problem. I don't know the length of these legs, but here's what I do know. The two legs are equal length. That means I could use the same letter to stand in for both of them. When we don't know something in math, we'll use a letter to stand in for it. So that's what I'll do. I'll just use an L for leg, okay? So I have an L here, and I have an L there. And you might say, Kate, how's that going to help me? Well, I have a relationship. Even though I don't know the length of the legs of this triangle, I do know its area. I know its area, and I want to know the length of those legs. And so what I'm going to do is I'm going to bust out that area formula. Okay, the area of a triangle, and you might be saying, Kate, but I'm supposed to find perimeter. Yeah, but I don't have the information I need for perimeter yet. So I am going to use the area formula to get the info I need so I can find the perimeter. Let me show you what I mean. So A is equal to 1/2 times the base times the height of a triangle. Now look, there's a lot that I know. I actually know A. I know the area of my triangle. It's not a mystery. It's 32 square inches. So where I once saw A in my formula, I'm going to plug in 32. Now be careful when you're using formulas not to change where equal signs are and not to trade or change out or lose any numbers. Okay, but you can trade out letters. Now, you might say, but Kate, I don't know the base and the height. No, you don't. But what you know is that they're the same. We decided to call them both L. So I'm going to trade out that B, base, for an L. And I'm going to trade out that H, height, for another L. And what I have here is two L's multiplying. And what I have here now is an equation to solve. Now I'm going to tap into my algebra skills. Okay, so in algebra, we simplify before we solve. And I see some simplifying I know how to do. I know how to simplify L times L using exponents. So let's do that. Okay, I can't simplify the left-hand side. 32 is just 32. And so that'll be equal to 1/2 of L times L is the same as L squared. Cool. So I simplified my equation, but there's no more simplifying I can do. It's time to start solving, working to get L alone so I can figure out what that length of a side is. Okay, remember to move anything multiplying first, so I'm going to move away that 1/2. And I think the way I'll do it is by multiplying by the reciprocal 2. I think that's the quickest, easiest way to get rid of a fraction. Now, of course, we can do whatever we want as long as we do it to both sides. Let's see how that helps us. Well, 1/2 of 2, of course, is just 1. You know, it just went away. It canceled out. And so all I'm left with on the right-hand side is L squared, like I wanted. And on the left side, I have 64. And now I'm almost done. L is almost alone, but I have to get rid of a square. Well, the opposite of square, of course, is square root. So I'm going to square root that side. Now you can do whatever you want to an equation as long as you do it to both sides. So let's see what happens. On this side, squaring and square root cancel, so L is alone. And the square root of 64, of course, is 8. Now, I know it could also be -8, but you're never going to have a length of -8 inches. That just doesn't even make sense. So just 8 is fine. Okay, so that being said, now I know that this side is 8 and this side is 8. Now I have the information, whether I use the formula or I just add up the three sides, to see the perimeter of this triangle. The perimeter of this triangle is going to be what I get if I add up the 11.3 hypotenuse and then the 2 8s for the legs. The second side and the third side were equal to 8. And let's do that. 11.3 plus 8 plus 8 gives me 27.3. And 27.3 what? Well, perimeter is just a line around the outside of a shape, so it'll be measured in plain old linear inches. And woo! No wonder Robin sent me that one. That was challenging. Definitely, if you have any questions, drop them in the comments. Again, just a reminder that this is probably a little more challenging than would be on the GED, although they do like problems where you go back and forth between area and perimeter. This one was particularly challenging, but it was great reasoning. Oh man, we had to practice so many of the skills we've been practicing, so I don't think that it was wasted time. All right, if you have any questions about this or any other GED math topic, be sure to drop it in the comments and I'll do my best to answer them.